second half of section 8.3, inequalities with absolute value. Now we're only going to deal with greater than. Well, I say only, but be careful on your homework. There might be one or two that have a less than also, just to remind you. So make sure you're watching for those symbols today in your homework. All right, so inequalities with absolute values that are greater than. In this case, now remember we said absolute value is distance from 0. So now if you have the absolute value of x, the distance from 0 is greater than 5. Well, what we have is this. So 5 is our endpoints, -5 and 5. If I want my distance from 0 to be greater than 5, that means we're going to go away from 0. We want the numbers to get bigger and bigger, so they're going to go to the outsides of our graph. So if you'll remember, this is the same as the compound inequality with OR. So this is going to be a statement with OR. And you're going to have x is, so x is either greater than or equal to 5, or x is less than or equal to -5, because it could go that way also. So that's going to be how we come up with our steps for greater than. So solving absolute values with inequalities with greater than, step 1, isolate the absolute value. It doesn't do any good if the absolute value isn't by itself. Then you're going to make your two inequalities. What you're going to do with those inequalities, once again, you're going to flip your symbol first, take your absolute value symbols away and flip it, and make your value negative. You're going to have an OR statement, and then your second inequality is going to just stay the same as it was. You're just going to remove the absolute values. All right, and then you're going to solve and graph. So it's exactly the same as yesterday, except that your symbol is faced the other way, so your graph is going to go to the outside edges instead of to the middle, making an intersection. Okay, so you're going to have a union instead of intersection. So on the first example we have, it is isolated already, so we don't have to do that. Once your absolute value is isolated, then you're going to go to step 2 and make your two inequalities. So x, your absolute value is x minus 2. You're going to flip your sign and make your value negative. So is less than or equal to -5, or x minus 2 is greater than or equal to 5. Leave it just the way it is. Now just solve them. Add 2 to both sides. X is less than or equal to -3, or add 2 to both sides. X is greater than or equal to 7. So now when we graph, we're going to graph here. We've got -3, and x is less than -3, so it's going to go this way, and it's equal to, so it's got a hard, the square end. Or x is, there's our 7, x is greater than 7, so it's going to go to this end of our number line. So all of this part is part of your answer, and the number line is part of your answer. Okay, you need both of those for full credit. Okay, see if you can work this one faster than I can. Okay, it's the same exact thing we just did. The absolute value is already isolated. So now get rid of the absolute value signs, switch the symbol, make it less than -5, or keep it the same. -3x minus 4 is greater than 5. Now solve each one, add 4 to both sides. -3x is less than -1, divide by -3. Oh, watch it. This is where I messed up last time. If you divide by -3, make sure to change your symbol. So x is greater than 1/3. Add 4 to both sides. -3x is greater than 9, divide by -3, so change your symbol. So x is less than -3. So x is greater than 1/3, or x is less than -3 is part of your solution, and then be sure to graph it just to make sure you've got -3 and 1/3. And you want less than -3, so it's this direction with a soft end point. And then greater than 1/3 goes to the right with a soft end point. And there you go. And if you have open circles on that soft end point and closed circles on the hard end point, I'll take that too. All right, here we go. The next one, 2 more. Isolate the variable. Okay, let's do it. Or not the variable, the absolute value isn't by itself this time. So make sure to watch for that. If the absolute value isn't by itself, you can't start anything yet. So subtract 1 from both sides. So 3/4 x minus 2, absolute value is greater than or equal to 6 minus 1 is 5. 5 seems to be a theme going on here. Okay, so now remove the absolute values and make your compound inequality. So 3/4 x minus 2, switch it, is less than or equal to -5, or 3/4 x minus 2, leave it all the same, is greater than or equal to 5. Solve. Plus 2 on both sides. 3/4 x is less than or equal to -5 plus 2 is -3 times 4/3 on both sides times 4/3, and this time it's positive, so I don't have to worry about messing up. X is less than or equal to -4, or let's do this side, add 2 to both sides. 3/4 x is greater than or equal to 5 plus 2 is 7 times 4/3 on both sides. Anytime you have a fraction, just flip and multiply, times 4/3. So x is greater than or equal to 7 times 4 is 28/3. Let's graph it. So this is the number part of our answer. Now the graph is -4. Less than -4 is to this way, and we've got a hard end point. And 28/3 is going to be right around 9-ish, so 28/3, and it's greater than, so it goes that way, and it does have a hard end point. There we go. There's our ends. Last one. So isolate the absolute value. So add 2 to both sides. Absolute value of 1/3 x minus 4 is greater than -7. And now, hopefully you said, whoa, 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 whoa. You've got a negative on this side, on the opposite side of your absolute value. And hopefully you noticed, wait a minute, something's not right here. So if this was an absolute value equal to a negative number, or if this is an absolute value less than a negative number, this is going to be a null set or an empty set or no solution. This cannot be. However, if this is an absolute value is greater than a negative number, this can happen because anything you get in here is going to end up being a positive number because it's an absolute value, and an absolute value is distance. It's always positive. So whatever you put into this x, you're going to take the absolute value of it and you're going to have a positive number on this side of the inequality. A positive number is always going to be greater than a -7 every time. So anything you put in for x will make this true. So your solution is all real numbers. So if your absolute value is greater than a negative number, your solution is all real numbers. Anything will make this a true statement. Now this is the only time that's true. If the absolute value is equal to or less than a negative number, then it's no solutions. But if it's greater than, it's all solutions because every absolute value is greater than a negative number. Okay, same thing as last section, except that now we're looking at the ends of our number line instead of looking for an intersection in the middle. All right, so don't forget when you make your two inequalities, you're going to switch it. Instead of greater than, you're going to have less than the negative, or you're going to have greater than whatever you already have. All right, you're doing great. See you next time.